Hello, my name is Martin Kronberg. Welcome to the IoT Developer Show, Season 4. In this episode, I'll tell you about FPGAs, or Field Programmable Gate Arrays. You'll learn what they are, how they work, and some of the unique characteristics that make them ideal for AI-based vision inference applications. FPGAs can be used for offloading computer vision tasks onto hardware that increases efficiency. They are similar in this way to a VPU, but the way in which they operate and how you would develop on them are different. Let's take a closer look into what these devices are. Fundamentally, they are programmable hardware. Unlike CPUs that perform operations by loading and running software, programming an FPGA means changing the actual hardware design of the device. You can think of an FPGA as a collection of logic, I/O, and data processing hardware blocks arranged for a specific task. The main type of blocks are logic elements, which are a collection of logic gates, lookup tables, and registers. These logic elements are combined to create all sorts of computational functions on the FPGA. Digital signal processing blocks, which handle multiplication and addition operations, critical for filters in a convolutional neural network. On-chip memories, which can be used as data buffers, pipelines, and for nearly any kind of on-chip storage operation. There are also hardened interface blocks such as DRAM controllers, PCIe, and high-speed serial transceivers. These blocks have a fixed functionality which are not built from logic elements. Tying these blocks together is the routing fabric, which is configured for the specific FPGA design. The FPGA blocks and fabric are configured into a custom hardware design by a bitstream. You can think of it as an FPGA image. When the FPGA is powered on, the bitstream is loaded into the SRAM of the device. To change the function of the FPGA, a different bitstream can be loaded into memory. How do you create a bitstream for the specific task? Well, FPGA developers use specialized design tools to convert a high-level hardware description into a bitstream. The good news is that this has already been done for you. The Intel distribution of OpenVINO Toolkit includes several precompiled bitstreams for the most popular neural network topologies that you can use in your solution. The toolkit also comes with all the software that you need in order to load your bitstream onto the FPGA. So, now that you know a little bit more about FPGAs, let's discuss why they are particularly good for accelerating vision inference. First and foremost, FPGAs boost system performance. FPGAs can be designed to perform many operations in parallel, much more so than a CPU. In general, hardware is faster than software. FPGAs do not waste processing time fetching instructions and data as they are defined by the hardware itself. FPGAs have lots of fast, on-chip local memory to minimize access times and reduce latency. You can also store and access large amounts of data through multiple interfaces. Because of these characteristics, FPGAs provide excellent inference performance with very low latency and are ideal for managing large networks with billions of parameters and large image formats such as 4K. FPGAs also let you adapt to changes. As new network topologies emerge or custom topologies are needed, FPGAs can be tailored to fit the unique requirements for each application. It's as simple as loading a new bitstream into memory. Finally, FPGAs are more resilient than standard computers and can operate in harsh conditions for extended periods of time. Many FPGAs run 24/7 in very hot industrial environments where they are used for monitoring product quality or worker safety. As part of Intel's quality process, FPGAs are stress tested to accelerate silicon failure mechanisms. It ensures production devices can operate for over 100,000 hours continuously in extreme temperatures. So, that's the basic overview. If you'd like to learn more about FPGA technology in general, you can download the free FPGA for Dummies book brought to you by Intel or watch the online training. In the next episode, we learn how to use FPGAs with the Intel distribution of OpenVINO Toolkit to accelerate your vision tasks. As usual, all the links are provided, and I'll see you guys next time.
Thanks for watching this video. If you liked it and haven't seen any of our other videos, subscribe to the Intel Software YouTube channel. You can also connect with other developers and enthusiasts in the comments. See you all next time.